Good morning. My name is Peter Gavina, and I'm back again trying to find the square root of a random number using a method that I have developed myself in order to more effectively accomplish this task. I'm randomly picking out a number. I have the number 7. Let's see if I can put it up here. 7. See what other kind of number I can get. 7, 1. And one more. There we go. 7, 1, 0. So that is our number. And we're going to see if we can actually calculate the square root of this number. When I say calculate the square root, I mean find a rational expression that is reasonably close to the square root of the number. I hope I've made myself clear about that. Now I'm going to erase this x, which was just a marker, and this is our number, 710. I want to find the square root of that number. The strategy I'm going to use is I'm going to break this number into two numbers, the product of two numbers, one of which is going to be a perfect square, the square root of which we know. And then I'm going to remove that perfect square from the square root sign and convert it to its square root outside the radical sign, and we'll be left with a smaller piece, which we will apply the same method to until we wheedle the number down within the radical sign to something more and more closely approaching 1, while a series of products on the outside of the radical sign will approach more and more closely the square root of the number that we are trying to find. So let's see how this works in practical terms. I have a number 710, and my first task will be to find a perfect square that is close to this number, but that does not exceed it. And by doing so, this will facilitate our future calculations. So I know that 300 squared is not, 30 squared is 900, 20 squared is 400. Let's try 25. 5 times 5 is 25. 2 5 is 10, 12. 2 5 is 10. 2 2 is 5. Here we get 625. That's not terribly close. Let's just try and make it a little closer. The closer we get it, the more closely it will facilitate our calculations later on. 6 times 6 is 36. 2 6 is 12. 2 6 is 12, and 15, 2 6 is 12, 2 2 is 40, 5, 6, 5, 7, 6, 7, 6. That's pretty close. So I think we're going to go with that. So what I'm going to do then, so I'm going to lengthen that radical sign a little bit to fit something else underneath it. And that very thing that I'm going to put underneath it is going to be 676, and we're going to divide it by 676. And as you know, 676 divided by 676 is just 1, so I'm not really changing the value of what is in the radical sign there. Now I am going to do something a little sneaky. I'm going to take the 676 and I'm just going to put it under the 710 here. 76. And if there is any doubt, I'm going to lengthen this symbol a little bit so that we know it includes everything that I've written down there. And my next step is going to be to break this into two square roots. Remember I said originally that I'm going to break this number 710 into the product of two numbers, one of which is a perfect square, and that I have already done, as you can see. there's the perfect square, and here's the other number, and this, of course, equals 7/10. I'm now going to break this into two square roots. Why can I do that? Because the square root of a product of two numbers is equal to the product of the square roots of those individual numbers, and that's all I've done here. Finally, I know what the square root of 676 is. It just happens to be 26. So I'm going to rewrite my expression. I'm going to replace this by 26. I'm going to rewrite my expression 26 times the square root of 7/10 over 676. Now, some of you may be wondering, have we actually made any progress? Well, as we go along, we shall see if we have made any progress. I would like to convert this to a decimal. So I have 676 into 7/10. And this will facilitate our calculations later on. I have 1, 6, 7, 6, 6. Okay, so there we go, with a little number there. Now that we have a decimal, you can see I'm not really interested in using a calculator. So I have this funky decimal. So finally I have 26 times the square root of 1.05022958. Now what I'm going to do is, you see this number, which is 1 and a small decimal, and I'm going to introduce the theorem that the square root of such a number is approximately 1 plus half this decimal point part, and that's it. I'm just going to use that as a ballpark estimate because generally it's true, and I could show you later on why it's generally true. It's actually going to be somewhat less than half of this, maybe between 0.5 and 0.4 of whatever this number is. So it gives us some idea of what it might be. And this will help us because when I see 1.05 and the rest of that, I just look at this as a 4, and about half of this, less than half of this, is 1.02. And so I believe I'm going to be able to get a perfect square by multiplying 1.02 times 1.02. This will give me a perfect square that will get us close to this number without exceeding it. 2 4s at 2 times 2 is 402, 201, 40401. So 1.0404, 1.05, you see it's somewhat close. So what I'm going to do then is, I'm going to do the same thing that I did before. I'm going to, let me keep this number here. I'm going to multiply and divide this by 1.0404 and divide it by 1.0404. And we know we can do that without changing the value of what is underneath the radical sign. I'm then going to move this over here, 1.0404. And finally, I'm going to break this up into two square roots, which I'm allowed to do by the rules of the game. And I already know the square root of this. It's 1.0404. The square root is 1.02, which is how we generated that number. So now I have 26 times 1.02 times the square root of 1.05022958 divided by 1.0404. Great. I'm going to convert this to a decimal. 1.0404 into 1.05022958. Let's see what we get here. Okay. What I'm going to do now is I'm going to rewrite this now. It's 26 times 1.02 times the square root of 1.00951. And remember, my rule of thumb is about half of this is going to be the square root of this number. Well, what it's going to be a square root such that when I square it, it's going to come close to this number. So I'm going to generate a perfect square using this rule of thumb. A square root close, the square root of this number is 1.00. Make that an 8, so it's 1.004. 1.004. 1.004. Is that funny? Okay, 4 times 4 is 16, 0, 4, and then 401. So 160801. So I've generated a perfect square, which is 1.008016, 1.00951, which is close to this using my ballpark estimate. I'm now going to multiply this by 1.008. 016 and divide by 1.008016. I'm going to change the denominator, 1.008016, and then I'm going to break this up into two radical signs. I'm going to take the square root of this. I already know it's, I have 26 times 1.02 times 1.04 times, what else? Okay, I'm going to do times this quotient here, 1.00951 divided by 1.00816. Now, what I'm going to do is I'm going to take the quotient here, turn it to decimal. 1.00816 into, if I did this right, into 1.00951. Now what I'm going to do is I'm going to get a real, you'll see what I'm going to do. 4, 8, 10, it's going to be 4. And I'm going to stop here because I'm going to make it approximately just that. And now we'll see that I'm going to erase this number here and just turn it into approximately 1.0014. I'm really lowballing it because there are numbers going to follow that, because I know that the approximate square root of this is 1.0007. So, and I'm going to stop there. I'm not going to go through all the calculations. I'm just going to take my result. I already know I'm just going to sort of replace this because I know that I'm going to have numbers following onto this, and if I multiply 1.0007 by itself, I'm going to get a number which is going to be close to my whole number, but that does not exceed it. So I finally get these four numbers, 26 times 1.02 times 1.004 times 1.0007. And we're going to multiply these numbers by each other, and we're going to see what we get. So we get 2664447. And I'm going to take that, I'm going to multiply it by itself and see if we get our square root. See how close we get to 7/10. That is, see if this is really a close square root to this number by multiplying it by itself. But I'm only going to take 6 digits because otherwise I'll be here all day. It's going to be 2664447. Let's see what happens. 5, 6, 7. Okay, so we end up getting 709.94. I guess that's reasonably close. 96 to 15. Let me check this here. 15, 20, 34, yeah. So this is what we end up getting by just taking that number of digits. We get 709.94. The number we saw was something that would give us 710. So we're a little bit off. 709.9. Had we taken this a little bit farther, we could have gotten an even more accurate measure. So I would say that's reasonably close, and if we carry out this method farther, as I said, we'll get a better and better approximation to our square root. Thank you.